number 9, and also your mock test. Okay, and same like yesterday, I want you to mark your quiz 9 and mock test by yourself and see how you did on your test and quiz. Okay, so so we will start with your mock test. Okay, so for mock test, so question 1A, automatic washing machine commonly used in a household is an example of open loop control system. Discuss why automatic washing machine is an open loop control system. So this question is three marks. So you must have at least saying at least these 3 points. Okay. So the first point is you must say that automatic washing machine requires you to give a preset, let's say preset time or preset temperature for the machine to work. And after that, there is no feedback behavior of the system of the washing machine. And you also say you also must have the sentence saying that in the presence of disturbance, for example, when your friend or your cousin stops the machine, and then you start or you restart the machine once again, then the desired cleanliness or the output will not be the same as what you actually want. Okay, so when you have these 3 points, you will get 3 marks. Okay, so the first point you must have is, so the first point is you must say the machine runs according to a preset time or temperature or speed. So irrespective of the process completed or not. Okay, so meaning that the process will run according to what you said. Okay, let's say you said to wash the clothes for 1 hour, so it will run until 1 hour. Sometimes if you stop and you continue, then it will continue the time that is left. Okay, for example, if you stop at 30 minutes, then it will continue the remaining 30 minutes. Okay, let's say you stop and then you wanted it to restart from beginning, then you need to wait until it to finish for the 1 hour. Okay, so if you have this kind of points, or you said you write preset time, temperature, or speed, then you get 1 point. And then the second point is the system has no feedback. Or sensor that controls the behavior. So if you have the word no feedback or sensor, you get another mark. Okay, one more mark. And then the third point is You can say uh, in the presence of disturbance, or you can describe an example. Okay, what kind of disturbance? Maybe you say when your cousin stops the machine, then the cleanliness will not be the same as desired. So meaning that the system is um, will not will be unable to work when there is a disturbance. Okay, so when you have the word disturbance, or you describe an example, an example uh, that shows automatic washing machine is an open loop system, then here you get 2 more marks. Okay, so maximum marks is 3 marks only. So if you have let's say you have point number 1 and point number 2, then you get 3 marks. If you have point 1 and point 2, you get 2 marks only. So if you have all the points, you get 3 marks. Okay. Yes, any question? Okay. Apa yang berlaku? Okay, if you okay. Okay, if you have problems with your mic or something, you can just type in the chat. Okay, I will read. Uh, I will read the chat. Okay, so I write fixed time instead of preset time. Acceptable juga. Okay, so if you say the machine runs according to a fixed time, boleh juga. Okay, as long as you have some description saying that the machine works for a given specified time ke. So output not compare with input is something similar to point number 2. The system has no feedback. So if no feedback meaning that the system cannot compare the output with input. Okay, so you get 1 mark for saying the word output not compared to input. But the most important thing is you describe an example about disturbance. Okay, that's the key point. That shows how different is open loop compared to closed loop. So the accuracy depends on calibration. Uh, tak kot, sebab washing machine nak calibrate apa. There are some systems that requires calibration. For example, like maybe like machine in your mechanical materials lab, for example. Tensile strength test machine. It has some control system in it. So it requires calibration. So if you don't calibrate, then maybe it will produce some error, okay, due to disturbance. So the idea is that open loop system is easily susceptible to disturbance. So uh, if there are disturbance, then open loop system uh, cannot control the output that you desire. While for closed loop system, because of the sensor, because of the feedback, it somehow reduce the effect of disturbance on the system. Okay. All right. So we go to the second question A2. So A2, in your opinion, how would you convert an automatic washing machine to become a closed loop control system? Design a block diagram of the new closed loop system, automatic washing machine. So most of the automatic washing machine is not closed loop. So the question asks you for your opinion. So if you answer add a sensor, or if you give some example of sensor, maybe cleanliness sensor, for example, or maybe a sensor that measures how many bacteria in the clothes, for example, that somehow measures the cleanliness, then you will get 1 mark. So if you say my opinion, add a sensor. So any sensor. So you can give example of sensor that you want, or you can just say add a sensor. Okay, because to make the system closed loop, you can say add a sensor or add a feedback, something that compares the output with the input. Okay, so if you have the word add a sensor or add a feedback or add some mechanism that compares output with input, you get 1 mark. Okay, and then after that you will have to draw the block diagram. So for the block diagram, you can start with the input. So input maybe input cleanliness or input temperature, for example, input time. And then it must go through a summing junction, okay? And then after that, it will go through a controller. And then maybe timer. And then after timer, maybe you go to washing process. And then output. And then put the sensor and feedback. And because open loop system is susceptible to disturbance, you put disturbance here. Okay, so if you have the elements of the control system, which are the input, output, the plant. So washing process or washing machine is the plant, and you have the controller. So if you have these 4 things, input, output, the process, and the controller, you get 1 mark. And if you have summing junction, 1 mark. You have sensor and the feedback signal arrow. You get 1 mark for signal arrow and 1 mark for sensor. And 1 more mark for the disturbance, okay? Because you want to show how closed loop actually reduce the effect of disturbance. So you have all of this, you get 5 marks. All right, any questions? Switch on boleh ke? Okay, so if you replace, let's say, controller with switch, I think acceptable because it sometimes switch also something like a mechanism that controls the system. So timer, actuator, actually actuator is the motor of the washing machine. So you can replace timer with motor. So the one mark, the star here, if you recognize all the elements of the control system, which are the input, output, the plant, and the controller. Okay. If you add actuator or if you miss the actuator, it's fine as long as you have these four elements: input, output, controller, and the process, the plant washing process. Okay, because these four are the elements for the control system. So timer, heating element, acceptable. Okay, so heating element tu something like actuator juga.
Sir.
Yeah.
Kalau antara 4 tu ada 3 je.
Let's say you forgot washing
Saya
process.
tak ada washing process. Saya ganti dengan clothes, baju.
So sebenarnya cloth is the item. It's not the machine kan. Maybe 0.5 ke.
Alright, sir. Thank you.
So you must let's say later in final exam ke, if you have this kind of question, you must recognize or mesti list out the elements of the control system. Okay. So washing process, cloth is part of the item. It's not part of the system. So macam it's not really correct. Okay. Okay, so we move on to question B. Okay, so question B is about block diagram reduction. Okay, the system in figure 1 shows a block diagram. Determine the transfer function GS equals YS over XS by reducing the block diagram. So if you have a block diagram reduction question that is very high in marks, so here's 16 marks. So what you are expected to answer is to give indication on what sort of arrangement of the block diagram. For example, here, these two blocks here are in cascade. So if you say these two are cascade, you get 1 mark for that, okay? Some of you straight away simplify. So if you straight away simplify, that is suitable for a lesser marks, okay, for that question. Let's say question is maybe 7 marks only. So you can straight away simplify without giving indication, saying indications such as a cascade ke, parallel, or move the pickup points, for example. But since this is 16 marks, so you need to specify what process you do and what sort of arrangement. Okay, so there are 6 steps for simplifying the block diagram. So the 6 steps are first, you look for cascade. And then the second one, you look for parallel. And then the third, you look for feedback. And then if you have no more of these 3 arrangement, nanti saya discuss macam mana pemarkahan dia untuk Irfan Hadi. Okay. Alright, so if you have no more of these 3 connections or arrangement, then you need to move peak off point. Okay, move peak off point. So pick off point to the right. And then the fifth step is move summing junction to the left. And then lastly, you repeat the process. Okay, so some of you move pick off point to the left and summing junction to the right. Okay, I think it's correct, but maybe you will get the final answer different from the actual answer. So the steps given here are the optimal steps. Okay, meaning that if you do, let's say, move pick off point to the left, for example, you are actually making the system more complicated. Okay, so if you move to the right, you actually simplify the system more compared to moving the pick off point to the left. So just follow the steps. Okay, even though sometimes you feel that moving it to the left is the best way, but it actually complicates the system. Okay, so we look at the question and see how to simplify the block diagram. Okay, so here, first you need to move this pick off point. Okay, even though this is cascade, you can simplify this first. Okay, cascade. But I want to simplify this first because later we can simplify this cascade and make it parallel all together. Okay, so here you move pick off point to the right, okay, to this. So you move this pick off point to this section. So you can write first step, move pick off point to the right. Okay, so if you maybe some of you redraw the question and you indicate something like this. So if you indicate, then and then you write some description, you can get 1 mark. Okay, and then you actually redraw and show the calculation of moving the pick off point. So so you move the pick off point here to the right. So basically uh, you calculate 1 divided by this. Okay, so it will become s over s plus 1. Okay, so if you show this calculation here, you get 2 marks. Okay, so some of you maybe forgot to divide. Maybe you write s plus 1 over s, but you know to move pick off point here, so maybe 1 mark for that. But if you correctly shows the calculation or show the values in the block diagram, then you get 2 marks for showing this. Okay, and then the next step, you can what you can do is maybe you can say these two cascade. So, and then you say these two here are parallel. So if you have indication that these two blocks are cascade, you get 1 mark. And then if you have indication these 3 blocks are in parallel, you get 1 mark. Okay, kalau move to the left macam ni? Itulah kepayahan dia. If you move to the left, tak tahu. Dia bukan kosong terus. If you move to the left, there is your score is not straight away 0. But I think you have to give marks based on your own judgment, because if I mark the question, then I will see the next step first. Okay, let's say you move this to the left instead. So what I will do is that I will check for cascade. If you have cascade, if you have parallel, the other things first. Okay, after that, then I will decide what to give for moving the pick off point to the left, because sometimes you move to the left, you get the correct results, but sometimes, most of the times, your results are not correct, but you are not losing all the marks. You will still get marks, but um, you need to give your own judgment for marking this. Okay, but for me, I will give marks for the other things first before the pick off point, because you already moving the pick off point to the wrong direction. Okay, so here you have cascade and parallel, and also these two here are also parallel. So another mark here. So 3 marks. And then you can redraw the system to simplify the drawings. So here you will get 2 over s plus 1 plus 1 over s plus 10. And then s plus 1 over s. And then s over s plus 1 plus 1 over s. Okay, so if you have 2s plus 1 here, which is from the cascade, you get 1 mark. And if you have a plus here, plus 1 over s plus 10, you get 1 more mark. Okay. And then here, if you simplify this, you get this, then you get 1 more mark here. Okay, after that, you will see that these 2 blocks and this one are in cascade. Okay, so you can say these 2 are cascade. And then you can also say that this feedback here, this arrangement here are feedback. So if you have cascade 1 mark, feedback another mark. Okay. And then you can simplify. So this becomes mm, and then so if you have this one mark, and if you simplify the feedback, you get another mark here. So markah untuk effort berapa? Ah, aduh. Ikutlah suka hatilah. Kalau kita simplify dalam kotak tu for parallel ada markah juga ke? Simplify dalam kotak tak ada markah. Just putting like this here, you get marks. Okay, if you simplify, tak ada markah je. But if you put plus or you put the simplified version without showing calculation, you just put this, you get 1 mark. Dari awal saya move to the left. Itulah yang saya kata tadi, tengoklah ada cascade ke, ada feedback ke. Saya rasa cascade dengan feedback ni, rasanya ramai yang buat cascade dengan feedback. Dengan parallel, sorry, cascade and parallel here. Pening lah move to the left. Tahu pun. Okay. So maybe you get 4 marks, 4 markah dekat sini, okay? 4 marks by simplifying cascade and parallel. And then try to see for other arrangement that you can, maybe after you move this to the left, you get this cascade. Okay, when you get this cascade, these two, maybe you give yourself another 2 marks ke, something like that. Okay, saya tak tanda part ni, tak tahu nak letak markah ke tak. Bagi kosong. Aduhai. Sir, boleh tunjuk balik mana markah confuse pula. Okay, kita start balik. Okay, so the first mark is your, when you say move pick off point to the right. Okay, so if you move your pick off point to the left, jangan bagi markah lagi. Wait first and evaluate for other steps, okay, other methods that you did. Okay, after you move the pick off point to the right, then you show this s over s plus 1, then you get 2 marks. Okay, meaning that move pick off point to the right and the final calculation for pick off point, you get 3 marks. Okay, 3 marks for pick off point. So maybe if you move the pick off point to the left, maybe you get 1 mark or maybe 1.5, because maybe you move it to the left and you show the transfer function in the block uh, as correct. Okay, calculation for the transfer function is correct, so you give yourself 1.5. Maybe if you move to the left but your calculation is wrong in this box, maybe 1 mark, maybe 0.5. Okay, and then after that, these two are in cascade, these two box. So you get 1 mark for cascade, and then this two box is parallel with this 1 over s plus 10. So you get another mark indicating these three boxes are parallel. And then if you indicate these two boxes as parallel, then you get 1 mark. And then after that, you simplify. So you simplify cascade into this, you get 1 mark. And then you put plus to say that this is parallel, you get 1 more mark. And then you simplify these two parallel into this, you get 1 more mark. And then the next step is you indicate this to as cascade and then feedback with this. So if you say these two are cascade, you get 1 mark. And then you show that you indicate that these three boxes are in feedback, you get 1 mark. And then you simplify this to cascade, you get this, the top one, the numerator, you get 1 mark. And then you do the feedback calculation correctly lah, okay, plus, and then with the correct transfer function, you get 1 mark. So the last 3 marks will be from indicating this cascade, 1 mark. And then simplify the cascade. Panjang sangat. So you simplify the cascade. Times okay, so if you have this, so if you have this multiplication of the two box, you get 1 mark. Kena tanda sampai terlebih markah pula rasa. Oh, hebat sangat tu. And then the final answer will be to get the final transfer function, the simplified transfer function. So the simplified transfer function will be Okay, so you can further simplify. Okay, I don't have the final answer, but uh, if you get a simplified version, you can get 1 more mark for the final answer. All right, that's for the question mock test B. Okay, so sometimes in your final exam, you are given block diagrams. Okay, block diagram, maybe uh, something similar to this, and maybe you are not given the values yet. So here the values are already given. Maybe you are given, let's say this is G1, this is G2. After you simplify, then then for the next question you are given some values. So you need to substitute the values into the answer, the transfer function answer. And then after that, maybe you are going to do some analysis, maybe analyze the stability using Rad-Hurwitz table, or you need to draw some graph to plot some graph. Okay. So what I want you to do is to go back to learning about simplifying the block diagram. Okay, learn about reducing the block diagram, because you can easily lose marks if you are unable to do the reduction correctly. If you lost marks for the first question, then for the next question you will lose maybe most of the marks. Okay, maybe all of the marks. So it's the same thing as drawing the free body diagram. So if you draw the free body diagram wrongly, then the subsequent question will be hard for you to get marks. Okay, so try to understand the steps, try to study the notes. Okay, all right, so
So,
Adulan. Okay,
kalau macam kita tak buat indication tapi jawapan semua betul, dapat berapa sir?
separuh. Sebab markah dia banyak. Okay, 16 markah. Tapi kadang-kadang uh, kadang-kadang masa menanda final exam, kalau ada soalan yang sama lah, kadang-kadang lecturer dia macam bagi je markah, bagi je full mark macam tu. Ada je kadang-kadang tengok kalau perform sangat, dia potong je. Dia tengok berdasarkan prestasi. Kalau macam full mark, macam dapat soalan lain pun dapat jawapan yang markah yang tinggi, dia tolak markah, macam okey je tolak, still dapat A macam tu lah. Okay, so we move on to the next question, which is the quiz number 9. Okay. Okay, quiz 9 will be about Rad-Hurwitz criteria. So quiz 9.1. Using Rad-Hurwitz table, determine the stability of the following transfer function. Okay, so you are given clues already, so you can follow the steps. Okay, so first step is to determine the polynomial of the denominator. So here you are already given the polynomial. Okay, so for example, the polynomial in previous question, the block diagram, the simplification of block diagram. So it's very long. So you need to simplify the block diagram until you get something like this. Okay, something more simplified, so that you can do the Rad-Hurwitz. Okay, so try to simplify as best as you can. Okay, so here the denominator is s power 5 minus s power 4 plus 4s cubed plus 4s squared plus 3s minus 2. Okay, so you start with the the row S5 because this is the highest power, okay, for the polynomial. So you start with S5 followed by S4. Okay, so then you fill the coefficient alternatingly. So you start with 1, minus 1, and then 4, 4, 3, minus 2. And then you calculate for row S3. Okay, so the best practice is to show the first determinant. Some of your friend in section 2 asked me about do they need to show the determinant. So the best practice is to show the first determinant if you feel lazy, okay? So just show the first determinant and the rest may be understandable, okay? So maybe you show the first one. And here you'll get 4 plus 4. So you get 8. But in my example, I will show all the determinants, okay? So here 1 minus 1, 3 minus 2, divided by minus 1. So you get minus 2 plus 3, 1. You get 1 here. And here is 0. And then for the next row, so you get minus 1, minus 32. So 33 over 8. And here, this will be 2 minus 2. And this is 0. And then for the row S1, okay, some values, okay. And then here will be it will be 0. S0 will be minus 2, okay. All right, after this, you need to look at the first column for stability. Look for sign changes in first column. Okay, so in the first column, you have first one sign change here, another one here, and then I think this is positive. So one more sign change here. So there are 3 sign changes. So meaning that 3 poles on right hand side of S plane, and therefore system is unstable. Okay, so if you have the word unstable, you get 1 mark. If you have all the calculation, you get 1 mark. Okay, so maybe if you think you calculate, maybe you get only one sign change. For example, maybe tolak lah 0.5 minus 0.5. Okay, because it's a very small marks, only 2 marks. So you don't need to minus 1 mark and then get 0, even though you write the correct answer. System is unstable. Maybe lost 0.5 marks, something like that. Okay. All right. Any question for question 1? Okay. So we look at question number 2. So for question number 2, it's a bit complicated, but not so complicated. So the question asks you to determine the range of K to make the system stable. So this kind of question is very famous in final exam, okay? Because oftenly you are required to determine the range of K for stable system. And you are given maybe a block diagrams. So the block diagram may be something similar to your mock test, okay? A bit complicated. You need to simplify first and then get the final transfer function and then use Strauss-Hurwitz criteria. So for this case, you need to simplify this. So this is a simple simplification. So you can say this two is feedback. And then you show the simplification, maybe ys over rs equals k over okay, so you simplify the transfer function. So if you know this is feedback and you simplify the transfer function, you get 1 mark. Okay, and then you simplify the denominator to get the complete polynomials. Okay, so here you will get s power of 4 plus s squared 4s squared d4s. Okay, I hope this is correct. Okay, and then you use the denominator and then do the Strauss-Hurwitz criteria. So here your denominator will be so you start with S4 followed by S3. So S4, S3. And then you fill the rows alternatingly. So 1, 5, 24, 20, K, 0. And then you calculate the determinant for S2. So minus 1, 5, 24, 20 divided by 5. You get 20 minus 100, 20. 100 divided by 5, you get 20. And then here, 1, 5, K, 0 over 5. So you get K. And then for S1, so here 5, 20, 20K over 20. So you will get 400 minus 5K over 20. And here you will get 5, 20, 0, 0. So you get 0. And then lastly, S naught. So for S naught, determinant of 20, 400 minus 5k over 20, k0 divided by 400 minus 5k over 20. So here you will get k. Okay. So then you need to look for the first column for stability. No sign changes in first column. So here, positive, these two, and these two are positive again, and these two must be positive. So this value here must be positive, meaning that for row S1, 400 minus 5k over 20 must be bigger than 0. So you'll get k less than 80. And then the next one is this k. So these two must be positive, and k, meaning that k must be bigger than 0. So for S naught, k must be bigger than 0. And then after that, you get two ranges here. So you need to combine them together. So k must be bigger than 0, and k must be less than 80. So therefore, this is the range for stable system. Okay, so you'll get 1 mark for having the right range, and 1 mark for calculation steps. Okay, and 1 more mark for simplifying feedback. Okay. Okay, any question? Okay, then we move on to the last question for quiz 9. So the last question, quiz 9, question number 3. Sorry, question number 3. So determine the range K to make the system stable. Okay, so this is a bit complicated because it has more blocks, okay, compared to question number 2. Total 5. Question 2 tadi 3. Okay, question 3 baru 5 markah. Okay, so the first 2 marks is first you simplify cascade and then feedback. So if you have cascade, feedback, and simplify, you get 2 marks here. And then you calculate, okay? You simplify the system. So CS over RS is okay. So if you have this and this. So you get 1 mark for saying cascade feedback, and you actually show the calculation to simplify. And then 1 more mark for getting the final transfer function. Okay. So here the final transfer function will be and then you further simplify. Oh, tak ingat jawapan. So you will get okay. So to simplify the feedback system from this to this, you need to I will say cross multiply. Okay, my method is cross multiply. So you multiply this here, and then plus all of this, and then this you just remove. Okay, so you write this the top here on top here, and then you cross multiply this with 1, and then plus this value here, and write all of them as the denominator. Um, it requires experience to cross multiply. Sometimes you are confused how to cross multiply, but this is my way. Okay, my method of getting the simplification here. Okay, so if you feel confused, you can take time to calculate slowly. Okay, don't rush. As long as you get the final denominator correct. Okay. Okay, so after you get the denominator here, so you can use this for the route Hurwitz. Okay, so just now this, if you get the right denominator, you get 1 mark. Okay, and then you can use the denominator for the route Hurwitz criteria. Okay, so after you simplify the block diagram and the transfer function, try to group them into the coefficient for each s. Okay, s power of 3, s power of square, power of 2, s power of 1, and s power of 0. Try to group them together before doing the route Hurwitz table. Okay, so after you group them together, you can start with s power of 3 followed by s squared. So s power of 3, s squared. So you fill the box alternatively, sorry. Okay, 1, 5.6, 11K plus 12, and 45 plus 10K. And then you calculate for row S1. So here you will get 1, 5.6 plus K, 11K plus 12, 45 plus 10K divided by 5.6 plus K. So this will equal 11K plus 12. and this is 0, then followed by S naught. So S naught will be determinant of this, and 0 divided by this. So you can write all of them back once again, or you can simply take 45 plus 10k. Okay, and then after that you can look for the first column. So for stability, uh, look for sign changes. In first column. So first, these two must be positive. Okay, so this is positive, and this thing must be positive as well. So row S2, 5.6 plus k must be positive, meaning that k will be bigger than minus 5.6. That's the first range. And the second one is this value here must be positive. So row S1, you will get 11k plus 12. Okay, this one will be bigger than 0. So simplify, you will get 11k squared plus 63.6k plus 22.2 bigger than 0. Okay, so you can use quadratic formula or your calculator because this is power of 2. So you will get two values of k. Okay, so two values of k. So first k is minus 5.408, and another one is k equals minus 0.3731. So what range of k? So you need to, if you still remember your form 4 at maths, then you need to uh, draw a quadratic curve, something like this. And the first point here is negative 5.4. And the second point is negative 0.37. And since this is bigger than 0, so you only need this range, okay? Meaning that k must be less than negative 5.408 or k bigger than minus 0.373. Okay, so you get three more range here. Two more range. So the first one here, and two more here. And then lastly, you look for the last row here. So this is also must be positive. So you can write S naught 45 plus 10k is also bigger than 0. And k must be less than 4.5 minus 4.5. Sorry, k bigger than negative 4.5. Okay, so you get three range here. First is k minus bigger than minus 5.6. The second one is k is less than minus 5.4 or k bigger than minus 0.37. And lastly, k must be bigger than minus 4.5. So you need to combine all these range together. So how to combine this? You need to draw them into number lines, okay? And see which of the range that all of these ranges intersected, or all the number lines intersected. Okay, so first you draw the lines. So we start with negative 5.6, and then followed by negative 5.4, and then negative 4.5, and lastly negative 0.37. So the first range says that k must be bigger than negative 4.6. So you draw a line in this direction, okay, meaning bigger than negative 5.6. And then the second one says k is less than minus 5.4 or bigger than minus 0.37. Okay, so two lines but in the same alignment, okay? And then lastly, k must be bigger than minus 4.5. So here k bigger than minus 4.5. So you get these number lines. And now you look at which ranges has the most intersections of the lines. So here, for this range here, only this line is intersected, okay? So this is not the range. And then this range here, between minus 0.6 and minus 5.4, 5.4. So only two lines intersected, but not this line. So not this one. And then the next range is in between minus 5.4 and minus 4.5. So only two lines intersected. This one, only this line intersected. So not this range. And from minus 5.4, minus 4.5, and minus 0.37, you get only two lines intersected, but not this line. So not this one as well. And for range bigger than minus 0.37, so here you get all the lines intersected, okay? All the range here are intersected because this line is in the same alignment with the second line here. So it's still considered part of the values or range. So here you know that this is the correct range. Then for stability, therefore for stability, k must be bigger than minus 0.3731. Okay, so here you get 1 mark if you get the right values for k, meaning that you get this correct, and this one correct, and 1 more mark for getting the right final answer. Okay. All right. Any question for this?
Sir,
Yep.
saya punya answer yang range tu saya ada dua. Yang K
Okay.
greater than minus 0.373 tu saya ada. Lepas tu saya ada lagi satu.
Sparrow, 0.5.
Alright, sir. Alright, sir.
Okay. But sometimes in exam there are a lot of ranges. Okay, when you calculate, you get more than one range. Okay, so you need to get only the right range. Okay, so you need to determine the optimal range. Okay, so by using number lines here. Okay. Okay, so that's it for today. Okay, so what I want you to do is to mark your own answer, compile all quiz 9, mock tests, and also your midterm tests together and send to email bmm3613. Okay, and try to understand or read more about the reduction of block diagram and also about route Hurwitz. Yes, okay, combine PDF lain sekali. Combine sekali all of them together if possible. Okay, if not possible, send them in one email. Okay, send them in one email. Do not send them separately. Nanti pening banyak sangat. Okay. So what I want you to do is to understand block diagram reduction and also understand route Hurwitz criteria. And then because next week we will move into next chapter, chapter 4. So in chapter 4, you will use block diagram reduction. You will use Radhowitz criteria. So if you still confused about these two methods, so it will be hard for you to catch up, okay? Because next week, the topic is probably the hardest in AC, okay? In BMN 3613. Okay, so that's all for today. And if you have any question, um, you can ask now, or you can leave because that's the end of our class. Okay, so thank you and see you next week. Assalamualaikum.
Waalaikumsalam. Thank you, sir.
Thank you. Sir, the submission is Sunday, right? Yeah, submission is Sunday before 11:59 p.m. Thank you. Project pun Sunday. Sunday 11:59 p.m. Thank you. You're welcome. Mache. Thank you, sir. All right. Thank you. Thank you for coming.